Hello everyone, good evening.
Good evening, sir. Yeah.
Okay, so today we have week 9 activity session. Before that, uh, how many of you have completed the week 9 content till now? Or you are doing till week 8 for the quiz only?
Sir, I started doing but not covered full.
Even I, sir. It's not completed.
Okay, so do you guys have any doubt in week 9 till now? Or shall we take up week 8 doubts if you guys have any?
Week 8, like I am having much difficulties in week 8.
Sir, I have a
Oh,
doubt
same
in
here, sir.
activity 8.7, sir. The doubt I asked you in discourse.
Okay.
Week 9, sir.
Okay, so let's just quickly, I think, wrap up the week 9 and then we will go to week 7, 8. Okay. So whoever's having doubt in week 9, please ask.
So question 4, 9.2, sir, activity 9.2.
Question 4. Okay. Okay, how did you proceed this one? Like, where are you facing difficulty? Of the code. Okay. So how did you approach this one? What was your approach to solve it?
Sir, I didn't get the question first of all, sir. Consisting of one symbol only, I thought 0 and 111. A and D.
No, symbols are these. A, B, C, and D are the symbols. Yeah.
Oh,
So-
not 0 and 1.
No. It's A, B, C, and D.
Okay,
And information generates symbol. Okay, I think we should replace it by alphabet. Yeah, instead of
In some
symbol,
bit-
there should be an
A
alphabet.
number of binary symbols 0 and 1 is there, sir, next to sentence.
Okay, yeah, it is mentioned over there. Yeah, so see, for x equal to 3 means the length of your code should be 3, right? You understood the random variable, what it is denoting.
Yes, sir.
Okay, so x equal to 3 means you should either get C or D, right?
3 length bit. Yes, sir.
Because for A length is 1, for B length is 2. So you should either get C or you get D, right?
Yes,
And
sir.
these two are disjoint even. Yes, it's only one alphabet would be there. So you can either get C or you can get D. You cannot get both of them together, right? It's not possible.
Yes, sir.
So probability of getting C union, like you get either C or D, it's union, right? So
Yes, sir.
it's
Union.
probability of C plus probability of D, because it is disjoint even, so intersection would be 0, right?
Okay, sir.
So I think this is given to you in the question, and this is also given to you. You can simply add them.
Okay.
So this is it's 1 by 8. So it's 1 by 8 plus 1 by 8. 1 by 4 would be the answer, right?
Yes, sir.
Is it clear?
Yes, sir. Yes, sir.
Okay. Anything else in week 9? Anyone?
9.4 question number.
Sir, 9.1, sir.
Okay, after this, we'll go to 9.1. Okay, 9.4, which question?
Sir, question number 2 in the option 3. Why this is a probability mass function? The probability is not adding up to 1. But option is saying this, all three are cannot be probability mass function. This can be how?
Which of the following can never be a probability mass function, right?
Yes, sir.
So first option cannot be because it has negative probability, is not possible, right?
Yes, sir.
For second one, the sum would be
Greater than 1.
greater than 1. Okay, for third one, the sum is equal to 1, right?
No, sir. It's not equal to 1. It's something 0.56. I don't remember, but not equal to 1.
Okay, it's 0.5 plus 0.25, which is 0.75, right? Plus 0.12, which is 0.87.
Mm.
0.97 and
Yes, sir.
the
Okay, sir. I'm my mistake. My calculation.
and in the last one the sum is exceeding 1. So yeah, this one is the only PMF possible. Right?
Yes, sir. Okay, got it.
Sir, 9.3, question number 2, sir.
Okay, yeah, someone was asking 9.1 before this. Is he here? Okay, 9.3, which question?
Question number 2, sir. Small doubt.
Okay, a length of rod of broken into 2 parts. Okay, let X denote the length of smaller part. Then which of the following statement is that true? Okay,
Sir, yeah, 0 should not be included, right, sir?
it can be.
Option 4. When it is included, it is not broken at all.
Yeah, it still have 2 parts, right? One is the complete 10 centimeter and another part is just
So
empty, no part.
not broken is also one of the case.
Yeah, it is. 0 means, yeah, it is also possible to have 0 over there.
Okay, sir. And 9.6, question number 4 and sir, 9 point in CDF, sir.
Okay.
It is step function, but in tutorial it's given vertical line. 9.6, question number 4, sir. Graph question.
Yeah, because we don't join these lines actually, because there is a discontinuity at these points, right? So
Yes, sir.
even in the lecture video, I think ma'am has joined it by dotted lines only.
So in
Don't
tutorial
generally
5,
join.
instructor drawn like vertical lines, sir. So I got confused between what to select. Tutorial 5, sir.
Let me see. So this one you are saying, right?
Yes, sir. Join vertical line join.
Okay. In general, we don't join it because there's a discontinuity at this point, right?
Yes, sir.
All this, so we don't join it. We show it by dotted line in general.
Okay.
Ma'am has
Sir,
also did the same.
9.1, sir.
Sir, please explain this positive skew and negative skew, sir. Skew.
Positively skewed and negatively skewed. Okay.
Yes, sir.
Positively. Okay. So before that, do you know what symmetric distribution?
Yes, balanced.
Balanced, right?
Yes.
If I join the midpoints of the bar section, it would be something like this, right?
Yes, sir. Symmetric.
Okay. And in asymmetric, we have two. One, could be negatively skewed and positively skewed, right? Skewed and positive skewed. Okay. So in negative skewed, what happens is the tail part is mostly in the negative, and all of your distribution is majority of your probability is on the right side of the center over here. While in the positive, you have a tail on the right side, and majority of your probability is in the left side of the region.
So skew means tailed distribution.
A skewed means like symmetric, it is balanced at this point, right? In the middle.
Yes, sir.
Negatively skewed means it is not balanced at the middle. It's balanced somewhere in the right side of the middle.
Okay, sir. Okay.
And positive skewed means it is not balanced in the middle. It is balanced somewhere in the left side of the middle. You will cover more on this in the stats too, but for now, this is the only thing you need to keep in mind for now.
Oh, okay. Thanks, sir. That's it. Thank you.
Anything else? Anyone?
So 9.1 activity, sir.
Okay, which question?
So from 7, I have doubts in various questions.
7. Okay.
Yes, sir. 2 cards. I mean, how to approach this question, sir?
Okay, you understood the random variable, but random variable X is actually in this case.
Yes, sir. I understood if exactly one card is face card, We are drawing
Yeah.
2 cards. So first card probability is 12 by 52, right?
12 by 52, right?
Uh,
And second card,
just a minute. Second card, it would be 40 by 1 by 40, right?
no, 40 by 51, right? Any of the 40 you can select. Your favorable cases are 40, right?
40 by 52, sir.
51. 51. We are drawing without replacement.
Yes, yes, we have drawn 1 card, so it would be 40 by 51.
Right? So in this case, you have taken first card as a face card, right? But it is
Yes, sir.
also possible that you can have second one as the
Second
face
also into 2.
card, into 2. Yeah, that's right.
Right, sir. Right, sir. Next question, sir.
Okay. The
This
small
I
delay-
understood, sir. Fine, sir.
This one is fine. Okay.
Yes, yes,
Next.
yes, sir.
This
This one, sir. 9th one.
Okay. Insurance salesman visit up to 3 clients each day. Okay. So each day he will approach 3 clients. Okay.
Yes, sir.
But
Sir,
as
what
soon as
approach I have taken
yeah.
is, sir,
Yeah.
he will approach 3 clients. So the chances of he selling a policy is, I have taken 3 clients separately. If he sells, if first clients buys the policy, then that is it. So it will be just one case right now, sir, for first.
Yeah,
For
it's-
second case, I consider as second one first one don't take the policy, second one don't take the policy, and third one also don't take the policy. There will be 3 no's.
3 no's, right?
I mean, did you get my point, sir?
Why did you take the first? Like here we have to find the value of probability x equals 0, right?
Yes, sir.
When will x be 0?
When none of the 3 buys the policy.
None of the 3 buys the policy. Okay, great.
Yes, sir.
So none of the 3 buys the policy means first client didn't buy, then second didn't buy, and then third didn't buy. Right?
Third didn't buy.
Yeah. So in general, if you look at it, if I suppose these are my 3 events, let's say event A is my first client didn't buy, okay,
Okay, sir.
and my event B is second client didn't buy, right?
Okay, sir.
And similarly, event C is third client didn't buy, right?
Sir.
So I need to find probability x equals 0. X equals 0 means all of these events are true, right? Occurring,
Yes, sir.
which is A intersection B intersection C, right?
Okay, sir.
And now you know that each client make its decision independently of the others.
Yes,
So
sir.
independence of events is given to you, right?
Okay, sir.
So we know by property of independence you can write it at like this, right?
Okay, sir.
And you know first client didn't buy the policy, its probability is 0.9, right?
Yes, sir.
Because
Yes, sir.
for buying it's 0.10, for not buying it would be 0.90. So
Okay, sir.
0.9 for A, similarly for B it's 0.9, similarly for C it's 0.9, right?
Okay, sir. Okay. Sir, how I approach this? There will be 4 cases, I think. I mean, first one buys the policy.
Okay.
None of the 3 buys the policy.
Right,
The first one rejects the policy. Second one buys the policy.
right,
And then first 2 rejects the policy and last one buys the policy.
right. Okay.
So that would
that's,
be 4 cases, no, sir? And
yeah, if
they
you
are
add
the
them
only
all,
4 cases possible, right, sir?
yeah,
So probability of he not selling the policy, that is x, then x will be 0. So I took the
Yes.
probability as 1 by 4, sir. Am I wrong, sir?
okay, you can take 1 by 4 only when each of these case has same probability, right? But here each of these case has different probability. Okay, let's
Oh.
consider, okay, for x equal to 0 means none of them by its 0.729, right?
Okay, sir.
Okay, now suppose x equal to 1, you have 3 cases in total that
Yes, sir. Right, sir. Right, sir.
you add them all, you will have different probabilities. So for all 4 cases, you will have different probabilities. So
Yes, sir.
we do that 1 by 4 when all my 4
Are equally likely.
yeah, all have the same probability, right?
So right, sir.
Here total number of cases.
Total number of
cases overall, buying a policy or not buying a policy?
Can you repeat?
Sir, here total number of cases will be 8.
Total number of cases will be
Will
eight.
be
No,
8.
okay, how
Sir,
will
each
it be
each
eight?
one has option to buy the policy or not buy the policy. Each one has 2 options.
Right.
2 into 2 into 2.
No, but here is a condition as well, right? He will stop.
No,
once he
no, sir.
makes
I'm
a
not.
sale.
I'm talking about without condition.
Yeah,
Overall,
without condition
sample
it would
cases.
be 8.
Yes.
But if here is a condition, that makes it total of 4 cases only.
Oh, yes, sir. Due to this condition.
Yeah.
Yes.
Okay. Okay. This one also.
Sir, yes, sir.
Okay. So what should be the answer according to you?
Sir, I didn't get the question, sir. If he goes for a wrong house and delivers a letter, will he take it back and deliver in the adjacent house, or as such? I didn't get the question, sir.
Okay. So what the question saying is there are 3 house side by side. Okay.
Right, sir.
And the postman has 3 posts. He is not sure whether which post belong to which of these houses. So he
Okay, sir.
randomly puts it in their delivery box.
Okay, sir.
So you have to find and the probability that he delivers 2 of the post at right.
Yes, sir. Yes, sir.
Okay. So if he has already delivered a 2 post in the right box, then third would will also be right, right?
Yes, sir.
It is definite case because third one cannot be wrong if first 2 are right, because there is no other option for third one to go wrong. It will definitely
Right, sir.
go right. So that's why there are 0 outcome for x equals 2.
Okay, okay.
Okay.
Okay, sir.
Okay.
11th is that is
Same as I think
listed.
question 8 and 9.
Yes, sir. Yes, sir. Question 8, na, sir.
Question 8, yeah. Question 8. Similar to question. Here
Yes,
you
sir.
don't have to find the probability, you have to find the number of favorable cases you have for x
Okay,
equal to
okay,
3.
sir.
Okay. That's what
Okay, sir.
cardinality of a set means.
Okay, sir.
Anyone, anything else in week 9? Or shall we move to week 8 for now? Okay. Okay, who has doubt?
Excuse me,
Yeah.
sir.
Yeah.
When can we expect the mock test question paper to be released? Because in calendar it is showing mock test discussion.
Yeah, mock test will be released Wednesday morning, and it will be available till Thursday 5 p.m.
Thank you, sir.
1 hour before the session.
Sir, could you please explain me like how Bayes theorem works? Because I couldn't wrap my head around it.
Yes, sir.
Bayes theorem.
Yeah, in sums, in numericals, like in the given questions. Like I got the theory how it works and
Can
all,
you
but like
explain
in questions,
8.7 activity question 4?
Okay. Okay. So Bayes theorem. Okay, you get the concept of Bayes theorem completely, like what it is
like
exactly is.
if an event A is happening, consider that B has happened. So you can find event B happening, consider that A has happened. It's like that, right? Probability of it.
You know the law
Am
of
I
total
right?
probability. Law of total probability, you know.
A union B.
No, it's not A union B. Okay. Okay. Consider a Venn diagram. Okay. Let's say this is the Venn diagram. Yes. This is my complete sample space. Okay. And suppose I did some partition to it. Okay. I did 3 partitions: partition 1, partition 2, and partition 3. Okay. And this, let's label it as E1, E2, and E3. Suppose my events E1, E2, and E3 are disjoint. And now suppose I need to find the probability of some event E. This is my some event E. I need to find its probability. Okay. So how can we approach this one? So I can make three parts of it, right? First part is this one. And second part is this one. Say your third part is this one. Is it clear till this step?
Yes, sir.
So what would be the probability of my event E? So probability of event E would be this probability of E intersection E1, right? This purple region plus probability of E intersection E2, this middle region shaded in the blue, right? Plus probability of E intersection E3, which is this third light blue region, right? Now using the multiplication rule, we can write it as okay. Is it clear till this step?
Yes, sir.
Yes, sir.
Yeah. So why do we use this law of order probabilities? Suppose I have my sample space S, okay, and yeah, I have this my complete sample space S, okay, and I know that there are some disjoint events like E1, E2, and E3, okay? And I have to find the probability of this complete event E. But due to some reason, I don't know about the probability of the C within this sample space, but I do have some information of occurrence of E if E1 occurs. Or I also have the information of what is the probability of occurrence of E when E2 occurs, and what is the occurrence of probability of E when E3 occurs. So I can simply add them all to get the probability of E, right? So that's what law of total probability states. You can partition it, and if you have some information of this event within each part, in each part of the partition, you can compute its probability like this, right?
So, sir,
Yeah.
here when you are telling E1, so E1, E2, E3, right? So those are the events which are like already happened, or like it is certain that it will happen, something like that, or how it is, or any condition is there on E1, E2?
E1, E2, and E3 should be disjoint. That's the only condition.
Okay. And anything about the probability of those events are there, sir? Like we know that.
Yeah, only information I know is I know about E1, I know about probability of E2, I know about probability of E3. Okay, and suppose I also have the information of occurring of E within this region, within the region of E1. In that case, I can also compute this, right?
Okay, so when you say, sir, that you have information about E1, E2, E3, means like within the sample space, right? Or
Yeah,
it is within the
sample space.
Okay. Okay, so you
I've-
have two information. One is event E1 within the sample space, as well as the event E within E1, right?
Yeah. In that case, I can compute probability of E as well using law of total probability, right?
Okay.
That's one step. So yeah, from this, okay, is this clear to everyone before we move to base theorem?
Yes, sir, it's clear.
Okay. So now let's consider a different scenario.
Excuse me, sir.
Yeah.
Sir, can you explain again with taking an example, like for example, two colored balls? It would be more. Like we have red and black balls in two bags.
Okay, let's take up some activity. Okay, let me just cover base with the same diagram and then we
Okay,
will look
sir.
at the
Okay, sir. No
question.
issue, sir. No issue.
Okay. Okay, now suppose you know the information about this event E. Okay. You know that event E has occurred. This event E occurred. This is the information you know. Okay. And okay, now suppose this event E has occurred. So if my event E occurred in this region, it will still be considered to be occurred, right? If it appears in this region, again it would be considered to be occurred, right? Or if it occurs in this region, it would again still be considered to be occurred, right?
Right, sir.
Is this thing clear? Okay, yeah. So I know that my E has occurred. Now I have to find the probability that it occurred in this region. Let's say this E3 region. So in general, I need to find the probability of E3, this region, given that my event E has occurred, right?
Right, sir.
So if you apply the formula for conditional probability over here, you will get this thing, right? This probability of E, you have already computed using the law of total probability, right?
Yes, sir.
And the numerator part, it is nothing but this third term of this equation, right? Is it clear till this step?
Yes, sir.
Okay, let's move on to a question. I need some 3. Okay. See, company A produces 30%. I don't think it could be
The fourth question.
this question.
A doubt in that fourth question.
I will cover it. I'm looking for some good.
Fifth and seventh is also good question, sir.
Graded assignment had some question for this type of theory too, sir.
Graded assignment. Number one machine question. Yeah, graded assignment.
The doubts will be taken.
Yeah, after this. Okay,
sir.
see. This is, an item is producing 3 factory A, B, and C. Okay. That's all I know. So suppose my sample space is all the items. Okay. I can split it into 3 parts. Let's E1 be those which are produced by A, E2 be those which are produced by B, and E3 be those which are produced by C, right? We can consider it like this, right? 3 partitions.
Yes, sir.
Of my sample space. Okay, moving further, we know factory A produces 2 times the number of items produced by factory B, and B and C produces the same number of items. See, from this information, I can conclude the individual probability of my events E1, E2, and E3, right? And how would we do that? Suppose factory B produces X number of items. Then C will also produce X, right? And A will produce 2X, because A produces twice as B. So in general, there are total 4X items, right?
Yes.
So what is the probability of this region E1? It would be 2 by 4, right?
Yes, sir.
For event B, it would be 1 by 4, and for event C, it would be again 1 by 4, right?
Yes.
See, my complete sample space, its probability should be 1. If you add all these 3, you will get 1. So I have partitioned my sample space into 3 parts: part 1, part 2, part 3, right?
Yes, sir.
Next is, okay, it is known that 8, 7, 2% respectively are defective. Okay. Now suppose this my event E over here. this event is that the product is defective. Okay. So what is we know the probability of this region, right?
Yes, sir.
Probability of being defective given that it is produced by factory A. It is known to us, right? Similarly, this region is also known to us. Probability of getting defective given that it's produced by factory B. And this probability is also known to us, right? We know about these three parts. We know the information of all this information, right?
Yes, sir.
These 6 information we have. Okay. Moving further, okay, all. Okay. Now I have selected an item at random. What is the probability? Okay, I think this would do. What is the probability? Okay, let's do it. That the selected item is defective. So a selected item is defective means I have to find the probability of E, right? So what I can do is I can find the probability of this purple region. This purple region is nothing but that probability that it was produced by factory A and it is defective, right? This is nothing but this thing. For second part, this light blue region, it is produced by factory B and it is defective, right? And for third part, it is produced by factory C and it is defective. And since I don't know the intersection value, so I use the multiplication rule and split it into these terms, which information I have available. I have this E given E1, E given E2, E1, E3, and I also know their individual probabilities. So I got the probability of getting a defective item. Is it clear till this step?
Yes,
Yes,
sir.
sir.
Now the next question states that we know that we have a defective item. You need to find the probability that it was produced by factory B. So now we know that event here has occurred. We have a defective item. I need to find the probability that I got the defective part from this region, from E2 region, right? So it would be probability of E2 given E. Again, you can apply the condition probability formula. You can compute. So you got when to use the base rule, right? You know that this event has occurred within this sample space, and you have the information about each of the parts, and you have to find the probability that the event which this event E has occurred in one of these specific parts. Here we are talking about E2, right? Is it clear when to use the base theorem?
Yes, sir. When the probability of in between is asked, we can use base theorem.
Could you repeat the last part again?
Last part again. Okay, see. So when to use the base theorem? When we have a sample space, okay? And within the sample space, we have some disjoint events which completely partition my sample space. Here I have complete 3 parts, right? Part 1, part 2, and part 3.
Yes, sir.
Right? And I know one, and I have information about each of these parts. That I know the probability of E1, E2, E3. Okay. And one event, this big event E, we know its probability of occurrence within each part, right? I know probability of E given E1, E given E2, and E given E3. These informations are given to us. Now what I have to find is the reverse thing, that this event E has occurred. You have to find the probability that in which specific portion of this 3 partition it has occurred. Here we have to find that it has occurred in the second portion, right? Probability of E2 given E.
Okay, we have to find that. I don't get what we have to find. I don't get that part.
Okay, you have to find that that item is defective. It is given to you. Okay.
Okay, item is defective, but it is from B, right? We have to find that.
Yeah, you know that item is defective. Now you need to find that it is produced by factory B. What it means is, you know that this big event E has occurred. Now you have to find the probability that it has occurred in this second part of your partition.
Okay.
Okay. I made it too messy.
Sir, can you solve the fourth
My answer was coming wrong. It came right in the third one, but fourth one it was wrong.
Okay, we will come to that. Is this clear? Everyone,
Sir,
Bayes
just
theorem
one,
and loss. Yeah.
just one doubt, sir. Like what I can see is whatever you have used in the total probability, the formula,
Yeah.
and the Bayes theorem, right? It is both are same, right? Or is there
Both
any?
are linked. Both are linked. Law of total probabilities, you are finding this probability of big event E
Yeah, but
using the
but
information.
in
Yeah.
intersection part, if you see, sir, you have again used that Bayes theorem only, right, sir?
See,
To
law of,
calculate
okay.
the
Yeah, to calculate, we are using it. So in law of total probability, what we do is we compute the probability of this big event E when we have information about each part, E1, E2, E3. Okay.
okay.
And Bayes theorem we use when we know that this big event E has occurred, and I need to find the probability that it has occurred in one of these specific part. Like here, if you have to find that it has occurred in part 2, so I will compute probability of E2 given E, right?
Okay. Okay. Yeah, got it, sir. Thank you, sir.
Is it clear, everyone? Before we proceed further, law of total probability and Bayes theorem. Okay. Okay. Anyone? Anything else?
So activity 8.7 question 4.
Sir, in the graded assignment question 1, have you already discussed it? The
No,
maths, Zahir Khan maths.
So can you
This one?
like clarify
Yeah.
the 8.7 activity question 4?
Yeah.
Yeah. Thank you.
So I had doubt in that graded assignment question number 1 too, sir. Like I didn't know how to approach it.
Yeah, we will come to that. Let's start with this. So that task is given to 3 students, Riddhi, Shivansh, and Prateek. Okay. Task individually is this. You find the project, task is completed. Okay, how did you approach this one?
I still the same way, like one student will complete the task at least one. So there are 3 ways one student can complete. So in that way of understanding I did it, but you clearly said like you don't have to choose a student, but I didn't
Yeah.
get that.
Okay, see, I have given the task to 3 students, right? Let's say R, S, and T are my 3 students. Okay. R, S, and T. I have given one task to these 3 students. Okay. And I need to find the probability that my task will be completed. Right? This is the thing we have to find.
Yeah.
Okay. What are the possibilities when task will be completed? Suppose my student R did it. Okay. And both others are not able to do it. My task will be completed, right?
Right, sir.
Like only one student can do it, right? One student does it, the task is completed altogether. So like 2 students don't have to do it.
Yeah, but it is possible, right? It is possible that
Because the
both
tasks
R
are
and S did it.
given them individually, right, sir?
Yeah, individually I've given it. Yeah, that's why these cases are to be considered. It is possible that both of them did it. In that case, also my task will be completed, right?
So can't we
Can
not
we do it
consider
with
1
contingency
minus 1 minus task is not completed?
It gets to be like something that they did it together or something like that. We can understand it, I guess.
No, each one is doing individually, right?
But the task is only one right here.
Yeah,
So-
only one. Okay, suppose this is okay. I have a problem in one question. Okay, one question I was facing some problem. I give this problem to 3 students, R, S, and P. Okay, that you go and tell me the solution by tomorrow. Okay, I given this task to them. So in how many ways will I get the solution? So
okay, I
only
get it.
only R is able to do, but other not.
Okay, I
These
get it. Okay.
I will get it. Okay.
Yeah,
So
I get it.
another easy way to approach is instead of adding these all 7, 1 minus none of them did it.
1 minus none of okay.
So that is nothing but R complement, S complement, P complement. And these 3 are doing it independently also, right? So I can simply compute it, right? Or you can simply add them on.
I think I did that 1 minus complement thing, but even that didn't get me 43 by 64. I don't know how that answer is.
Okay, 1 by 2, it's 1 by 64 if you product it off. Okay, let's do it.
Sir, can we do it by taking union of both three of them?
Yeah, we will do. Yeah, we can do it by that way. If you know the property of union of 3 event, you can do it. Okay, see, R is 1 by 2.
Actually, there is a complement. 1 by
Yeah.
2 into 3 by 4.
Yeah, so R complement would be
1 by 2.
1 by 2.
S complement 3 by 4. P complement 7 by 8.
right.
Sir, is there a way we can solve it without using the formula, sir?
Okay, shit.
Without using the formula means which formula you are referring? I haven't used any formula except this independence thing.
Yes, sir, right, sir. I mean,
I
without
got
going
it. So I didn't apply the independence rule here. So yeah, I didn't get the question properly. I got it. Thank you, sir.
Is it clear now, everyone? Or any doubt in it?
Yes, sir. Clear.
Sir, I have
Yeah.
doubt in graded assignment question 10.
Okay, we are coming to graded assignment as well. Let's go question by question. Okay, first question, you are able to do?
Yes, sir.
No,
Any
sir.
doubt in?
No, sir.
sir.
No, sir.
No, sir.
Please explain.
Okay. So, okay, I will go with these values in my question. Okay. Zair Khan has taken, okay, we know that he has taken 5 wicket hauls in 4 of his last 15 matches. Okay. And I'm randomly selected his matches one by one to analyze. And one match is only analyzed once. Okay, there is no match which has been analyzed more than once. This information is also given in this line. Then I have to find the probability that the 11th one analyzed is his last 5 wicket all match. Okay. So see, we know that there are total of 15 matches, right?
Yes, sir.
In which there are 5 wicket haul matches. Okay. And I need to find the probability that the last one means okay, let's do last 5 wicket haul one is analyzed in 11th match, right? Okay, what does this mean? In 11th match should be his 4th 5 wicket haul match. It means
3 matches have been 3 5 wicket hauls have already been analyzed before the 11th match.
Before 11th match, he has given 3 5 wickets.
Yeah, in the first 10 matches analysis, I must have covered 3 of his 5 wicket haul matches, right?
Yes.
Okay. So in how many ways it is possible? So out of these 10, okay, of these 4, I need to select 3, right? I need 3 of these 4. And in remaining 6 matches, it could be anything. The non 5 wicket haul match, right?
Yes.
11 others. So out of this 11, I need to select 7. So 10 matches analyzed, right? 15C10. So your total number of ways to analyze 10 matches of these 15 is 15C10, right? And in these 10 matches, I need 3 5 wicket haul matches and 7 others, right?
Okay.
Is it clear till this step?
So, but
Yes.
you're considering only 5 haul wickets, right?
Yeah, 3 5 wicket haul matches I need. 7 should be other because the 4th one should be the next one, the 11th one, right? 4th 5 wicket haul should be the 11th one, right? So before that, in my first 10 messages, I should have covered the 3 of them, right?
Sir, could you explain what is
Yeah.
4C3? You are picking any 3. What is 4C3?
4C3 means I am picking his 3 5-wicket haul matches of the 4.
Okay, you are picking any 3 out of these 4 5-wicket haul.
Yeah, and 7 others from these 11. Right?
Okay.
So in total, I have done 10 matches analysis. So these are my favorable cases where I have covered 3 5-wicket haul matches, and total number of cases are these, right? So your probability would be this, that in first 10 matches, I have covered 3 5-wicket haul match. So this is my probability of this, right? Next, we need the probability of this, that in this 11th match, it should be a 5-wicket haul match. So in total, I have 5 matches analysis left, of which only 1 is 5-wicket and 4 are others, right? And I am randomly picking up. So any match can be get selected with equal probability. So probability of getting this is 1/5, right?
Okay, got it, sir.
Is it clear, everyone?
So
Any
1 by
doubt in
5,
this?
5, sir. How did it get 1 by 5? Can you explain it again?
I have already done 10 matches analysis, right?
Yes, sir.
Now I am left with only 5 matches of these 15, right?
Yes, sir.
In these 5 matches, I have only 1 5-wicket haul match and 4 others.
Okay.
And I am randomly selecting any match for analysis. It means selecting any match has an equal probability, right?
Yes, sir.
So probability that I get this one is 1/5.
1
right?
by 5. Yes, sir.
I think that should be the answer, right? Is it clear now, everyone?
Sir, there you have chosen that 11C something is there, right?
7.
Sir?
Yeah.
Yeah. So already, sir, for we are analyzing the 5-wicket hauls, right, sir? Or
we are analyzing all the matches.
okay. Okay.
His match records are selected 1 by 1 and analyzed.
Okay. Okay. Okay.
All the matches we are analyzing.
Okay. I got it, sir.
Okay. So that's why I need to pick 7 others for analysis also.
Yeah. Yeah. So I thought it is only for 5 all matches. Yeah, got it.
Okay. Further, question number 2.
It is
You're able
different in this. It is different in this, sir.
Okay. Are you guys able to decode the English statement into events?
No, sir, that's where I'm
So
having
that is
issues.
the problem.
Okay. In this question also you face this problem.
Sir, like any guides or tip like how to decode these statements into events?
It's only practice. Everything is hidden on only these 1 and 2 lines. All the information. Okay, let's do it. Okay, see, A and B predicts the outcome of a cricket match. Okay, this is the one statement given to you. Okay, and their chances of predicting the runs scored by a specific batsman correctly are 2/5 and 2/6. Okay, so suppose let's me event. Okay, we need to find the probability that their answer is correct. Okay, and we also know that they are doing it independently of each other, right? And next one is probability of them predicting the same wrong score is 5/213. It is also given to me. I need to find the probability that their answer is correct when they have predicted the same score, right? So you were able to understand what is mentioned in the question till now, right?
Yes, sir.
Okay, let's do it in terms of the statement. So, okay, what all event we need? Event we need is they predicted the same score. This would be one of the event, right? Okay, let's make it. So one event I can make is
Prediction is same.
Yeah, they predicted same score. Yeah.
And the sir condition will be correct and non-correct.
Which condition?
Is it? It is given in the question. What will be the condition?
Condition. Okay, we know that this event has occurred. Predictive the same score, this event has already occurred. So conditioning on this, we need to find the probability that their answer is correct. Right? Is that your doubt or you're asking something else?
Yeah, same.
Okay. Find the probability that their answer is correct. Okay, let's say that let's say yes, let's make 3 more events. 3 would work. Okay. None of them predicted correctly. Okay. And other could be it's exactly one of them predicted correctly. And both predicted correctly, right? So if you look at your sample space, these 3 parts I can make, right, of my complete sample space.
Sir, in these
None-
three, even E2 in 3 and E3, you have mentioned correctly or incorrectly. But in event 1, you don't have mentioned anything. I didn't get
Which
that
event?
part. E1, E, sir.
Yeah, E is different.
Okay, E is
it is given to us, right?
Okay, sir.
See, event E1 is none of them predicted correctly, right? So this is the part
So
belonging
that
to this.
E will be what you have explained in total probability part. That
Yeah.
E, and even
E-
E2, E3 are disjoint events.
Disjoint event, right? So this is
Got
my
it,
vote.
sir.
Okay, and this is my event E.
E. Okay, sir.
But all information is given to us. Okay, let's look at the information. Do I know the probability of E1? Probability of E1? None of them predicted correctly. It means that A has predicted wrongly and B has predicted wrongly, right? And
Right,
I
sir.
also know that they are doing it independently. So I can do it by multiplication rule. I can do it, right? Because they are independent.
Yes, sir.
And I know the probability of them predicting correctly and incorrectly, right? I can compute this one. Right? So I have information about E1. Do I have information about E2? Okay. So E2 would be A predicted correctly and B predicted incorrectly, or A predicted incorrectly and B predicted correctly. Again, by using the independence, I can compute the probability of E2, right?
Right,
Now,
sir.
do I have the information about E3? Yes, you also have the information about E3. Again, using the independence, you can compute it, right? Okay, so now we know about these 3 events. Now, do we also know about this event E within this part? Let's check it. Okay. Probability of occurrence of E in my part E1, what would it be? They predicted the same score. None of them predicted correctly. If you look at it, probability of predicting the same wrong score, it is also given to us, right?
Right, sir.
So my E given E1 would be this given in the question, right? Given to us. Next, probability of E given E2. Well, now see, we know that exactly one of them predicted correctly, right? So it is not possible that they have predicted the same score. Because suppose 66 is the correct prediction and predictor A said 66. If predictor B also said 66, then they both must be right, right? But we are saying that exactly one of them predicted correctly. So it is not possible to predict the same score in this case, right? So it's 0. Is this clear?
Yes, sir.
So
Yes, sir.
please, sir, make repeat it again. So why is it 0?
See, we know that only one of them predicted the correct score. Okay. So
Okay,
it
sir.
is not possible that they both have predicted the same score and only one of them get it correct.
Okay, okay. Yes, sir. E
Right?
is predicting the same score. Yes, sir.
Okay. Next, they predicted the same score given that both of them answered correctly. So that's one, right? If we know both of them predicted correctly, then yeah, they must definitely have predicted the correct score. If they both have predicted a different score, then both cannot be correct, right? Is this clear?
Yes, sir.
Okay. So now if you see, I have the information about each of these part, E1, E2, E3. And I also have the information about this individual parts, event E in this individual parts, right?
Sir,
Yeah.
sir, I have this problem. Why this one E1, E3?
E1 given E3 is 1.
Yes.
Okay. Okay, it is given to us that both of them predicted the score correctly. Okay.
Yes, sir.
Now suppose correct prediction is 66. And we know that both predicted correctly means A has also predicted 66 and B has also predicted 66, right?
Yes.
Then it's definitely the same, right? If suppose A has predicted 66 and B has predicted 67, then both of them cannot be correct.
Okay, sir.
So that's why it must be the same. It's a certain event, right?
Okay.
It's your event.
Okay. So now see, we have information about these three parts, E1, E2, E3. And we also have information about this event E within each part, right? I know E given E1, I know E given E2, and I also know E given E3, right? Okay, now the question says, given that they predicted the same score, find the probability that their answer is correct. Given that they predicted the same score, find that their answer is correct, right? So now they are saying this event E has occurred. They have predicted the same score. Okay. Now you find the probability that this E has occurred in this third part, which is probability of E3 given E, right? So for probability of E, you can use the law of total probability, right? At E3 intersection E, you can do it, right? By using the E given E3, this information is given to you times probability of E3, right? Is this clear?
Sir, I have a confusion in the question here. They have said that the probability of them predicting the same wrong score. So
Yeah.
does it not mean E by S? E by S, they have not mentioned that E given E1 has occurred, that they have not mentioned. They have mentioned the probability of the same wrong score. So will it not be E by S? The probability, will it not be E by S here?
No.
Sir, I was wondering the same thing.
My event E is that they predicted the same score only.
No, not E by S, sorry. E intersection E1 by S. E intersection E1 by S.
E intersection E1, you are saying?
By probability. So is it not the in the question? Sir, please go to the question here. The question.
Okay. Yeah.
They have mentioned that the probability of them predicting the same wrong score is 5 by 213. They have not mentioned that probability of them predicting the same score, given that they predicted the wrong score, is 5 by. They did not mention it like that. They have mentioned predicting the same wrong score. So is this not the probability out of the total sample space? The probability out of the total sample space. I mean, probability of
these events are defined by us only. One can also change this event. Like you can also make some events like A predicted correctly, B predicted correctly, and then proceed further.
So, sir, just take the example. Suppose E intersection E1. Let us say it is 5. Let us say it is 5.
Okay.
The total event, that is the value of that event is 5. E intersection E1 is 5, and value of E1 is say 8, and the total sample space is say 20.
E1 is 8 and total sample is 20. Okay.
20. So the probability of predicting the same wrong score, can we not consider it as 5 by 20 instead of 5 by 8?
Probability of same wrong score.
Same wrong score, will it not be 5 by 20 instead of 5 by 8? Probability of them predicting the same wrong score, will it not be 5 by 20 instead of 5 by 8? If they have mentioned that probability of same score given that they gave the wrong score, then it will be 5 by 8. Otherwise, it will be 5 by 20. Will it not be 5 by 20, sir?
Well, see, you are saying total sample space consists of 20. Okay.
Yes.
E intersection E1 has my 5. So probability of E intersection E1 would be 5 by 20, right?
Yes, that is.
Okay.
So this 5 by 20 is what is given in the question, the same wrong score, is it not? They have not mentioned the probability of same score given that they were wrong. If the statement would have been that they predicted the same score given that they were wrong, then it would have been 5 by 8. But here it is 5 by 20, no?
No, see, here these events are defined by us only, right?
Okay.
It's not like that. See, we have to find a probability of predicting the same wrong score, right? Same wrong score. Okay. Should we go for it? Let's say. Okay, so you're saying
because what I did for this question was I considered that probability of the same wrong score is already given. I calculated
Okay.
I calculated the probability of the same right score, that is multiplication of the probabilities.
Same right score.
Same right score is multiplication of the probabilities. Then I simply put in the numerator the same right score and divided by the same wrong score plus the same right score. Same right score. So here the two probabilities are given as 2 by 5 and 2 by 6. So the probability of the same right score is 2 by 5 into 2 by 6. Same right score is 2 by 5 into 2 by 6, right?
The chance of predicting the runs scored by specific batsmen correctly are 2 by 5 and 2 by 6.
So the probability of them giving the same right score is 2 by 5 into 2 by 6.
If both predicted correctly. You are saying both predicted correctly.
Both predicted correctly is 2 by 5 into 2 by 6, right?
Okay, yeah.
So in the numerator, I will have 2 by 5 into 2 by 6.
Okay.
In the numerator, I'll have 2 by 5 into 2 by 6. And in the denominator, I'll have 2 by 5 into 2 by 6 plus 5 by 213. Because I'm adding the 2 because in both the cases, the score is same, but in one case it is right and other case it is wrong. So I'm adding the two cases, that is 2 by 5 into 2 by 6, that is 1 plus 5 by 213. That is how I did this question, but I got it wrong.
Predicted the same wrongs. Okay, but you haven't considered the ones where only one answered correctly, did you?
One answered correctly is the case where they did not get the same score. No, they will not get the same score if one answered correct. If one answered correctly and the other answered not correctly, then they will not have the same score. So I did not consider that condition at all, because in that case both will give the different scores. So that condition I did not score at all.
Okay, let's just write it down. Okay, so you are saying that given condition you are using, given they predicted the same score, right?
So the probability of they predicted the same score is the addition of 5 by 213.
So you are splitting it into
Right
two
and wrong.
parts. Yeah.
Right and wrong.
So in how many cases it can be either same right would be there or either same
Wrong
would be there. Okay.
Yes. Wrong
So-
according to the question is 5 by 213.
Right.
And
this
right is the multiplication of the probabilities.
2 by 5 times 2 by 6. Okay.
Right.
Right.
So you
okay.
add them, you get the probability of the same score.
Okay, let's say
You add
this is
them,
my
you get-
event E. So we get the probability of event E as
Whatever
it
the
will
addition is.
okay. Okay. We got the
So
probability of E.
why is it as a multiplication? We can 1 minus 5 by 213 can be a right score.
Right score.
We can write right score as 1 minus 5 by 213. If they're predicting the same score and they are wrong, then it is 5 by 213. So if they are predicting the same score and they are right, then it will be 1 minus 5 by 213. The multiplication I'm asking to the person who is telling this, why multiplication is done there?
Sir, because in that case, the total probably the total conditions will be like they predicted the same right score, the same wrong score, and both had given the different scores. So that condition we are not considering now because we are considering only the right.
It's only about the wrong thing we have. They predicted the
Yes.
same wrong score. It is also
Yes.
possible to get wrong in other ways by predicting not the same.
Yes.
That's
yes.
why we are not doing 1 minus. Okay.
What so please, sir? I can't understand this part only. That's why I'm asking this question. Why we are not getting 1 minus?
Okay. See, so but it is given its probability of getting wrong. A given predicted same, right? So it's 5 by 213.
So this is what I am confused about, sir. Wrong given E is not given here. Wrong given E is not given. It is given simply wrong same score. Wrong same score is 5 by 213. Wrong same score is 5 by 213. That is what is given here.
No, sir, is considered E to the event to be predicting the same score.
Predicting
na?
the same
wrong
score.
is-
I am considering
Yes,
it to be that event. Yeah.
Correct. Then after that, sir?
I am considering two events. One is they predicted the same score, and other one is they predicted the wrong score. So I am merging it like that. Wrong, same score. I'm predicting it, merging it like that. Given
So
they
this
predicted
is
the same
how
score.
this is how the answer solution is given. This is how the this is how the solution has interpreted it. But I interpreted it as 5 by 213, meaning that the probability of both of them getting the same score and they were wrong.
Okay.
So,
okay, let's just.
So now
the diagram would sort it a bit. Okay. See, this is the prediction made by A. This is the prediction made by B. Let's say. Okay. And your event E would be, I think, predicted the same score. So event E would be this.
event E would
see, this is the A's prediction. This is B,
yes,
and the same I am putting it up as here. Okay.
yes, same trade, yes.
Okay.
Out of this one, some are wrong and some are right.
Some are wrong, some are right, right? Okay. You are making its partition, right?
Yes.
It's right one and it's wrong one. That's how you are doing, right? As far as
Yes,
I'm
yes,
getting.
yes.
Okay. And now you are saying is we are given
Now,
this part. This
right one we know, so just put it in the numerator, and right and wrong one, that is the total intersection, we put it in the denominator.
Okay. Right part you are putting in numerator.
So 2
right?
by 5 into 2 by 6, and this addition which is
Denominator,
E by E.
you are putting it up here. Okay, but you haven't considered the probability of them predicting the same score as well, right? There will also be some probability assigned to it.
Sir, same score. They predicted the same score. The probability of them predicting the same score is the addition of them getting it right and the addition of them getting it wrong. So
Yeah.
the probability of them getting it wrong and the same score is 5/213, and the probability of them getting the same score and right is 2/5 into 2/6. So if you add the both of them, you get the probability that they got the same score.
So add them up, I will get the same score.
Yes, probability of getting the same score.
Okay, according to you, it's the intersection part, if I'm not wrong, right?
Yes.
You're saying something like that. Okay, so wrong and predicted the same score. Well, it's not okay.
So, sir, go to the middle slide here. Middle slide here.
Which slide? Okay,
The slide where you have explained the slide in which you had explained that, sir. The previous slide in which you have explained.
It will take some time. I think I have to undo it.
You have to undo everything. Okay.
But we also have to take into consideration the prediction of the same score as well, right? That's why we are computing probability of E. Okay, let's see how we are computing. We're computing it by law of the probability. Okay. Okay, yeah, let's switch to that Venn diagram. I think it might where you're done. So I got what you are trying to say.
Yes, sir. Here, what the solution is taking this 5/213 is this as we said, if we consider E intersection E1 as 5 and E1 as 8 and total S as 20, then the solution is considering the probability of 5/213 as 5/8 and not 5/20, but I considered it as 5/20. That is where I got it wrong.
Okay, and 3 will be only this much. Okay, so what we are okay. See, in this Venn diagram, what we did is we made these three even, right?
Yes, yes.
And the predicatedly exactly one
This
of the
Venn diagram is
predicatedly-
very clear to me, and only confusion I have is that E given even, E given even.
Yeah.
That is the 5/213 which is given in the question. But I considered it as the overall probability that they got it right. They got the same wrong answer. Overall probability, that is 5/20. If you consider the sample space as 20, then I considered it as 5/20 instead of E given even. So there was a confusion in understanding the question. Once I went through the solution, and once I went through the solution, I found out that where I went wrong is that I considered this probability of both getting the same right score as 5 by the total sample space instead of the 5 by the even.
Right.
That is where I went wrong in
See,
my
from the
understanding.
quotient statements, it should be even.
If the question was framed like the probability of them getting the same score given that they were wrong, probability of getting the same score given that they were wrong, then I would not have been confused in this question. I would have considered it.
Okay, you're saying the statement is like predicting given that they predicted the wrong score.
The wrong score would also same wrong score, no sir, same wrong score.
Yeah, so, yeah, that's what I should there. So what framing you are mentioning with the probability of them?
The same score given that they were wrong. Given that they were wrong, what is the probability that they got the same score. That if the statement would have been that, then it would have, I would have got this question right in that case.
No, see, in same wrong score, but here we are doing is we are merging these two events. Given they predicted the same score, we have to find out whether none of them predicted correctly.
Yes.
I got your point as well, but how shall I? But these are the things. See, when I was doing this question, I didn't face this doubt of E intersection E1 or whether it would be this, right?
Yes.
It is because I am habitual of doing. I have done a lot of these questions. I know that, yeah, that's what it means.
Okay.
But actually, can you put this query on the discourse? We will discuss with the team and hopefully
Okay,
it will provide you a
okay, sir.
good solution, right?
Okay.
Currently, I'm not getting like how can you explain this part? Can you put it on discourse? The same thing.
Yes, sir. Yes, sir.
Okay, just put it on discourse and we will discuss.
Yeah, sir. Just one doubt, sir. Here,
yeah,
whatever you have given the explanation, so the value it will be the complement, right? The E for a E1 or it will be the same value 5/213.
Which thing? It will be same, right?
But
even
here we are
given
considering the predicted correctly, right? And there it is saying that a wrong, like wrong score.
Can you repeat?
No, sir. In the question which is given the value, it is 5/213. It is that
right?
Wrong answer.
Both
right?
predicted the same wrong score. Yeah, same.
And but here we are taking the okay, we are taking the prediction correctly. No,
none of them predicted correctly. It is given to us, but it's the probability that they predicted the same wrong score. That the same score.
Okay, so
if
for
none
that,
of them predicted correctly, yeah, for that it was 5/213. Same wrong score, right? That's how we can write it.
Okay, yeah.
Given none of them predicted correctly, but is the probability that they predicted the same score. That's what it means, right? Same wrong score.
Okay, yeah.
Sir, after you, may I speak, sir?
Yeah.
So after you made your conditions, taking E
Yeah.
as getting the same answer, and even B getting no one gets the correct answer, predicted correctly, E2 is 0 because no anybody cannot predict a correct option with not predicting the same score. And E3, so there is only two conditions left. None of them predicted correctly, and both of them predicted correctly, as they're predicting the same score. So my answer question is just that if in the question it is given 5/213 that they are predicting the same wrong score.
Yeah.
And given that, and the answer question is asking, given that they predicted the same score, so what is the answer of predicting them right? So if they are predicting the same score wrong, 5/213, so it will be 1 minus 5/213 for correct. So why is it wrong?
Why is it wrong? Okay, see, you understood how we write this as E given even?
Yes, sir, I got it.
Okay, what is your event even?
The event even is getting none of them predicted correctly.
None of them predicted correctly, right? Which is this one.
This
So
one.
within this is within. So now your new sample space is this, right?
Okay.
So within this, you know that given this sample space, you know the occurring of this. So if you subtract one from it, you will get this remaining part, right? Which is none of them predicted correctly, and they have also not predicted the same score.
Okay. I got it. Okay. So later on, sir, why we are multiplying the same scores? Just for finding the same right score.
Yeah, both of them predicted correctly. It means A has given the correct prediction and B has given the correct prediction. So using independent, we know that both of them predicting independently, right? So using independence, I can multiply it, right? Intersection by.
No, I got the confusion because there was player score predicting player score, and can you open the question window, sir?
Yeah.
So in that it is written that A and B predict the outcomes of a cricket match, and their chances of predicting the runs scored by a specific batsman correctly are 2/5 and 2/6.
Yeah.
So I thought so 2 by 5 and 2 by 6 is their chances of predicting correct batsman score, not the match prediction. It is also the match prediction.
No, they are
Predicting it correctly.
predicting the batsman scores only, right?
Okay. By batsman score, they are predicting the scores of the cricket match.
Yeah.
Okay. So at the end, it will be 2 by 5 into 2 by 6
Yeah,
upon the
both will
whole.
be correct when both predict correctly, right?
Okay.
Chances of predicting A correct and B correct. Yeah, continue.
Means at the end, it will be like bias one, in which we are asking that if they are predicted the same score, what is the probability they are predicted correctly. So it will be 2 by 5 into 2 by 6 upon the whole probability, total probability of 5 by 213 plus 2 by 5 into 2 by 6.
Can you repeat the correct? Can you repeat it once?
Means it is just like bias. It is just like bias theorem. In the event of predicting the same score has happened, and we have to ask if they are predicted it correctly. So for predicting it correctly, the probability should be 2 by 5 into 2 by 6.
Yeah.
And upon that, it should be the whole probability of predicting the same score. That is 5 by 213 plus this probability. That will be the answer, sir?
No. Predicting the same score probability, you have to compute using law of total probability, right? This complete event E. Right? This is the probability of predicting the same score, right?
Okay.
So how would you compute this probability? You take this portion, right?
Yes, sir.
Then this portion.
The middle portion is zero. Middle portion is zero.
Yes, exactly.
Yeah, middle portion is zero. Middle portion we can exclude, right? Just okay. Middle portion we can exclude.
Okay. It will be 2 by 5 into 2 by 6 upon 5 by 213 plus 1. That is the probability of PE3 into PE.
You're saying it would be like I'm not getting it with numbers. Okay, so you are saying it would be 2 by 5 into 2 by 6, right?
This is the probability of happening of both
This
of them
E.
predicting the current score. P3.
Yeah, that's what we are computing, right? Probability of E3 given E, right?
That is what I'm saying.
Okay, let me just write it down over here clearly. They are computing this thing, right?
Yes, sir.
Okay, so it would be E3 intersection E upon probability of E, right?
Yes, sir.
So E3 intersection E, I'm using the multiplication rule. E given E3 times probability of E3, which is nothing but the same 2 by 5 times 2 by 6, right? In the numerator.
Yes, sir.
And the denominator probability of E, you need to use the base total law of probability, right?
Yes, sir. That exactly what I'm saying. P into P. Yes, sir.
That's
Exactly
0 part
like
for
that.
E2. Yeah, that's how you can compute it.
Ah.
You have all this information, right?
Yes, sir.
Okay. We are clear now?
Yes, sir.
Okay. Okay, question number 3, I think we just did, right? 3 and 4.
The fourth one, I have done the third one correct, but my answer for fourth one is coming wrong. And also, sir, I haven't got the graded assignment solution on my portal.
It's in the portal only.
No. I have some supplementary. Okay. I will see it right now.
Okay, so
I think this is the correct calculation error because third one is correct and fourth
one. Third one you are doing, fourth one you must do right.
Yes,
so, sir, just I have one doubt, sir. So, actually, I'm solving these problems via this contingency table, forming that table.
Yeah,
and
you
then
can
solving.
do that as well. You can do that.
Okay. So, but sir, maybe at the last question and a few questions are where I'm using it, but I didn't got the answer. So maybe later I can discuss when you go to the last question.
Yes,
these are
Gishant,
correct,
hello. I have also same issue. We can discuss after all the graded assignment questions are discussed.
Yeah, okay.
I have also same issue. We can discuss with sir.
Okay, moving forward. Question number 5. I think it is the same as the activity question we just did, right? Same task is given to 3 people. Here names are changed and probabilities are changed, right?
Yes.
Okay, question number 6. Were you guys able to do it?
Yes, sir.
Yes.
Any doubt in this question, anyone? Shall we proceed? Okay.
Yes, sir. I have a doubt in question number 6.
Question number 6. Okay.
I wasn't able to solve this.
How did you approach this one?
Sir, I had no idea about this.
Like you must have done something and must have reached some answer, or you weren't able to understand but all given something must be there, right?
Sir, I tried to draw a Venn diagram, but somehow, like,
Venn diagram. Okay. Okay. See, probability of A complement is given to you, right?
yes, sir.
And B complement is also given to you. It's
Yes, and A union B, probability of A union B is given, like whole area is given probability.
okay, and A union B is also given. I'm not just plugging in the value, I'm just telling the approach. Okay.
Okay,
So if
sir.
I know A complement, I can compute probability of A as well, right?
1 minus this.
I can compute probability of B as well,
Yes.
right? You know the A union B, this value is given to us, right? And
Yes.
you know the formula for A union B?
Number of A, number of B minus A intersection B.
B minus probability of A intersection B, right?
Oh yeah, probability.
We know this probability of A. We know
Yes,
this
sir.
probability of B, right?
Yes.
Another information is given to us is that A and B are independent. So I can write A intersection B as probability of A into probability of B, right?
Okay, okay. I forgot that part. Thanks.
There are two independent events. If independence is given to you in the question, it is very helpful to solve any question, right?
Yes, sir.
Okay, moving further. Question number 7. You have to do it. Question number 8, 9,
9, 10. So 9, 10, sir. In this, the 7th is right, but 8th and 9, 10, 10, I would answer is wrong. Coming wrong.
Okay. But is the probability that student is a average level?
I will check
Given
my
that,
position.
yeah, it will be the same, I think. Its values would be different.
Average, yes, sir.
Right?
The range is different between them.
Yeah. Values would be different in the table.
Yes, sir.
Okay, so given that investigation is done by researcher Y, so my new sample space is only this second row, right?
Okay.
Within that, you have to find the probability of being average student. So that's 20 upon this row sum, right?
Okay.
That's what given means. Whenever you are given some event has occurred, it is your new sample space, right?
Okay, means
So,
it's on. It will. We will only take researcher Y.
yeah, because it is given that investigation is done by researcher Y, right?
Okay.
Given that investigation is done by researcher Y, so our main focus is only on the results obtained by researcher Y.
Okay.
Now within that, you have to find the average. It is 20 upon the row sum, right? Number of students
Yes, sir.
researched by researcher Y, right?
And researcher X will be the same thing.
Yeah.
So please, sir, please explain the 11 questions, sir. I tried so hard. I made so many of modules, but I was unable to do so in this rain and heavy traffic.
Okay, in 11.
I will, if you want, I will tell you, sir, what I made. That in this, it is given that probably that one of the third days it will rain. So
Okay,
at first,
yeah, 11th one will take a time. Okay, is 12th one clear? After that, we will move to 11th one. 11th one, it's a long one. We will do it last. Is 12th one clear? Okay.
Yes.
Everyone? Or any doubt in the 12th one? Yeah, let's do the 11th one now. Okay. So, okay. So, did you get the 3 events? One is linking the rain, right?
Yes, sir.
Other one is some heavy traffic.
Yes, sir.
And third one would be arriving late to school, right?
Okay.
So these are the 3 things we are focusing on this problem, right?
Okay. Okay.
Okay. So yeah, just telling you. So it is given that. Okay, let me just define the event. So R means, let's say, rainy day. Okay. H means heavy traffic. And L means late for school. Okay. Okay. So now what information were you able to grasp from the question?
Sir, actually, I did so. At first line I read, it rains
Yeah.
1/3 of the days and affects students to travel to school. So out of the probability of raining, I took the probability of raining 1/3 at first.
Right.
1/3, and then after that, reading the question, yes sir, 2/3. Yes sir, that 1/3 will be rain and 2/3 will be cleared.
Clear,
So
yeah.
after that, I read there will be heavy traffic on a rainy day is 0.5. So in rainy day only, there is 2 probabilities. In rainy day, when they will rain, it will be chances of 0.5 of heavy traffic and 0.5 of no traffic. We can take it as that.
Yeah.
And in clear day, when there is a non-day, in clear day, there is also 2 probabilities. At first, it is 0.25 of heavy traffic and 0.75 of having heavy traffic.
Non-rainy day, yeah. Okay.
Okay, sir. And
Yeah.
after that, if it rains and then there is heavy traffic, the probability of students arriving to late school is 0.5. So at the first equation we made of which I was telling you the condition, when it is raining 1/3 and when it is heavy traffic, then it is 0.5 for student coming late to school. The probability.
It is R intersection H, you are saying, right?
Yes, sir. R intersection H, and then it is 0.5.
Okay.
Means it is raining, that is 1/3 probability of raining, and then it is 0.5 probability on a rainy day, that is should be heavy traffic, and in that heavy traffic the probability of student coming late to school is 0.5. Okay, after that, if it is a clear day and there is no traffic, means we are coming to 2/3 of clear day and 0.75 part. When there is no traffic on that day, there is 0.25 time of heavy traffic, we are coming to 0.75 of no traffic. Then the probability is reduced by 3/8. So at first I was unable to decode it, at which the probability is reduced by 3/8. So I just subtracted 3/8 from the 0.5.
Yeah,
that
that's
is the
what we have to
probability of that we have to do. So it will be coming around 5. If I get it, 5/10 minus 3, it will be coming around 0.125. It will come around 0.125.
Okay. See, what I noticed is, yeah, again here you are misinterpreting it. See, you interpret it right? First, it rains 1/3, so probability of raining is 1/3, and not raining is 2/3, right?
Yes, sir.
Next is probability that there will be a heavy traffic on a rainy day is 0.5.
Yes, sir.
So how will you write it?
That there will be heavy traffic on a rainy day. That we will write, sir, ki, R intersection H.
No, it won't be R intersection H. See, it is heavy traffic on a rainy day. What it means is, if given it is rainy day,
it is raining. Yes, sir. H/R. That, yes, exactly.
It would be 0.5, right?
Yes,
so that's what also in the same wrong score, the same thing.
Yes, sir.
I'm not getting the exact statement to explain, but that's the intuition. That's the same thing which you use for here. You could have also.
It is rained and it is heavy traffic also.
Yeah,
the
that's
probability
what
is
is the same wrong score.
Yes, sir.
The same score and wrong. So that was the thing, how we merge these two events, right?
Okay.
Okay, and okay, so yeah, and probability of H complement given R would also be
0.5.
Okay, yeah. Next thing, some given to us. Okay, let's see. And on a non-rainy day, heavy traffic would be 0.25, right?
Yes, sir.
Heavy traffic given non-rainy day, right? So not heavy traffic, non-rainy day, 0.75, right?
Yes, sir.
Okay, next information. I think next we have a lot of information. This, if it rains and there is heavy traffic.
Yes,
If it
sir.
rains and the probability of student arriving late to school is 0.5, right?
Yes, sir.
Probability of arriving late to school given rain and heavy traffic, right?
Yes, sir.
0.5. Okay. Next information given to us is
Probability of coming late if it is not raining, clear day, and there is no traffic. That is P late dash means probability of coming late, then R, yes, sir. R complement and H complement.
0.5 minus 3 by 8. So
Yes,
it
sir.
is something 1 by
Or-
8. Okay.
Yes, sir. 1 by 8. That is 0.125.
Okay. Next is in other possible situation, it's 0.25. So
Yes, sir.
what are
Exactly,
other
this is
possible?
the point, sir. Where should I put this 0.25? That is for me.
0.25, what 0.25?
This is the
Okay,
last
okay, that
condition.
thing. Okay.
Then there is
See,
other aspects.
what all possibilities you could have of being late? Rain and heavy traffic. Okay, let's make a table over here. Rain and heavy traffic.
Yes, sir.
Rain, no heavy traffic.
Yes, sir.
No rain, heavy traffic.
Yes, sir.
No rain, no heavy traffic, right? Only 4 possibilities are there. For first, you know the probability.
0.5.
Fourth, you know.
Yes, sir. Yes, sir.
But all the other two remaining, rain,
Okay.
no heavy traffic, right? And no rain, but heavy traffic, right? These are the two possibilities.
Okay.
And after that, if on a random a student arrives late to school, then what is the probability it rained that day? So given he arrived late, you have to find the probability of raining, right?
Yes, sir.
So for that, if you look, what all information you need R intersection late and probability of late. These two things you need to compute, right?
Yes, sir.
Okay, so rain and okay, rain and being late, right? So there are only two possibilities. Either there is heavy traffic and no heavy traffic, right?
Yes, sir.
So to compute this, I can compute these two probability.
Rain day, heavy traffic.
Not
Okay.
heavy traffic, right?
Yes, sir.
And how would you compute it? How would you compute it? For that, okay, let me do the one. We will be able to do the others. Let's consider rain, late, and heavy traffic. Okay, all these three.
Okay.
First term. So you know the multiplication rule. We can expand it. Okay, let's do it. I can write it as probability of L given R intersection H into probability of R intersection H, right?
Yes, sir.
This probability I know, right?
Yes, sir.
So
It is
0.5. Now rain intersection H, I don't know. So for that, I can write it as H given R into probability of R.
Yes, sir. H given R probability.
You know.
Okay, sir.
Similarly,
Yes, sir.
you can compute this.
Okay.
So you will get the probability of R intersection L, right?
Yes, sir.
Okay. Now, how would you compute probability of L?
Probability of late. We will.
That's our second thing, right? So in for being late, you know these are the 4 cases possible.
Yes, sir.
So I can write it as late, rain and heavy traffic, first case.
Yes, sir.
Late, rain and no heavy traffic, right?
Okay, okay. We have plus all the four.
Yeah.
Okay, it's like total probability. Understand it.
Yeah. Yeah. Again, you need to compute these 3 terms using this
Okay.
information, right?
Okay, okay. I will do.
Is it clear, everyone?
Yes.
This question.
Can
Yeah.
you explain the last formula which you have used? It, sir, intersection and then complement and then
Intersection and then okay.
Thank you, sir.
Yeah. Okay. Okay, let's do it in general. Suppose here we have to find a probability of rain intersection heavy traffic intersection late, right? Let's say this is your event A, R intersection H, and this is your event B. Okay. So how can you write probability of A intersection B using multiplication rule? You can write B given A into probability of A, right?
okay, yeah, we can break in that way, sir.
Yeah, now I'm plugging in the value. So B is L given R intersection H into probability of R intersection H, right?
Yes.
Now I know this value, right?
Yeah.
Now to find this value again, I can break it. H given R into probability of R.
But you are writing in the complement form, right, sir? Earlier, something like.
Okay, that thing.
Yeah, that one I didn't got, sir. Like.
Okay, so we need to find the probability of rain and late, R intersection L, right? So what all are the possibilities? One case is there is heavy traffic. One case is there is not heavy traffic, right?
Yes.
So to find this, I can add the 2 cases, rain, late and heavy traffic. Rain, late and not heavy traffic. By adding, I will get the rain and late probability, right?
Okay, sir. And one more doubt is there, sir, like when we can take it is given and when we have to take it is intersection part, like in heavy like traffic and that rain which used given rain. So can we not take like intersection, right, sir, that it is heavy traffic?
No, it won't be intersection. It is given that it is a rainy day, and then the probability of being heavy traffic is 0.5. See, these things you will get an understanding more you practice such questions.
Okay.
The only problem with this question is you are not able to convert English statements into event terms, right?
Yeah. Yes.
Yeah, that's if that thing you crack, it's almost done, right? Done and dusted.
Sir, I solved this question using Bayes theorem. When I took 4 disjoint events, the first event was that it was raining and it was heavy traffic. Second was raining and there was no heavy traffic. Third is it was not raining and it was heavy traffic. And fourth
these are
event
the
was
4 cases with break.
yes. So and I made this Venn diagram using that, showing these 4 disjoint events, and then I made a inner event E, having the event E was like the person had come late, the student had come late.
Yeah. Okay, great. Yeah. These are the 4 partition, and this is your event.
And then yes, and then I found the probabilities of all these 4 events, all these 4 disjoint events. And then I went about the Bayes, the formula of the Bayes rule to find out the.
That's what we are doing over here only. It's the same thing. I just didn't do the Venn diagram.
Yes. But the mistake I made was that I did not subtract 3/8 from 0.5. I multiplied 0.5 into 3/8, where I got the probability wrong. The probability 0.5
reduced
minus
by part.
Because it was reduced by 3/8. I thought that 0.5 into 3/8. But it was actually 0.5 minus 3/8. So I got the answer wrong.
Yeah, reduced by 3/8 means 0.5 minus 3/8.
Okay.
That was it. Okay.
So this approach
Okay.
is correct, no, sir? Making this for four disjoint events and then making
Yeah, that's what we are doing only here. It's the
Yes,
same
sir.
thing we are doing.
Okay, okay.
Okay. Yeah. Any other doubt in week 8? Anyone?
Yes, sir. Like I told, right? I am solving via this. So can we solve this problem via this contingency table, sir, or how it is? Or
Yeah, you can do the contingency table also. How you are making the contingency table? First, I need to know that. So yeah,
like,
contingency table is gonna be a bit complicated, but yeah, how did you make?
sir, actually, when I made it, sir, I was unable to consider this like heavy rain and not heavy rain. So that's the reason I think my answer got wrong. So like ideally, sir, it is like two cases, like rainy day and not rainy. We can make it in row, and other three cases we can take it like column wise. Sir. That is.
Why are you using contingency table method? You're finding it more convenient, is it?
Yeah, sir. Because earlier I was not able to understand Bayes theorem and all. So
Okay.
just.
And tree diagram, have you looked at?
No, sir, I have not looked at it.
Yeah, look at it as well. It's, I feel, more simpler than contingency table.
Okay.
Sir,
Okay.
where it is given? I didn't
So
find it.
It's not given in the lectures.
Okay, sir. As you have mentioned the tree diagram, I am interrupting in between. I have also find it very convenient solving tree diagram. For example, this rainy day and non-rainy day question, I find it like easiest question among all graded assignment in this graded assignment.
But tree diagram such become
Yeah.
easy.
Sir, you are far more experienced. Can you explain why the tree diagram is not included in the lecture? Because I find it very convenient and the questions are straightforward when we solve with a tree diagram.
See, in this.
Is there any, sir, disadvantage or is there any exception?
No disadvantage. See, only one method is covered in the lectures, right? But there are several methods to solve one single problem.
Just like permutation and combination, it's all about visualization and taking cases, and you can approach one question in many types, just like that, sir.
Yeah. So here also, see, ma'am could have done it. Ma'am started with contingency table and then come to the basic principles she is doing, because it is a foundation level course. But if you want to explore other methods, you can do it. It's up to you. Tree diagram, it's pretty easy to solve.
Yes, sir. It is pretty easy. But sir, I have a question respective tree diagram. I have also asked Prashant sir in last I think class, but his internet was not so good, so he said that we will do that in another session.
Okay.
In tree diagram, there are several cases. For example, if we see activity 8.7, I think last question, that cricket and football problem. So in the tree diagram, sir, we are just visualizing that mathematical representation, right? Which you are finding events. And so in that question, sir, how to visualize that questions in which the probability sum up is not up to 1? Like cricket and football probability it is not summing up to 1. Like it means that there is some sort of intersection bit among them, right? So how to approach that question, sir? Can you please take that question and solve it via tree diagram? It would be so helpful, sir.
Okay, we will do it. And before, let's see, for this question we are referring, if you make contingency table, it would be something, it should be some kind of 3D, right? Because you have three factors: late, rain, and then heavy traffic, right? So in such case, contingency table could be a bit complicated. Another simple way you can do is you can make two contingency table to solve it. Late, not late, rain, non-rainy, because this information is provided to you. Second set of information which is provided to you is late, not late, based on four partitions: rain and heavy traffic, rain and not heavy traffic, not rain and heavy traffic, not rain, not heavy traffic, right? So in that, from contingency table, you need to use these two tables to approach, right?
Right, sir. The problem, the more it get like difficult, the more it get difficult via contingency table.
Yeah,
I
the
found
more
it. Maybe
factors
it, yeah.
more factor it keeps on adding, it would be a difficult.
So could you
But yeah,
solve this question using tree diagram, because tree diagram is not in the
Yes, sir.
pictures.
Yes, a tree diagram.
Please solve it
It's
using
very
tree diagram.
this question. Okay, yeah, we
in
can,
rain problem.
Yes, sir. Rain problem.
Hello, sir.
Sir,
Where
please
this
explain
tree
how to
diagram
make.
is given.
can you repeat?
Sir, please also
Where this
explain how.
tree diagram is given.
Can you please speak one by one, both of you?
They are wanting you to explain the tree diagram approach, sir.
Okay. Okay, see, the first information which is given is raining and
Not
not raining.
raining. Not raining. Right, sir.
Okay.
The raining is 1/3.
Yeah, it's raining and not raining, right? Its probability is 1/3. It's 2/3, right?
Right, sir.
Okay, and after that, the information
Heavy
is
traffic, not traffic.
heavy traffic on a rainy day. It's
Yeah, heavy
0.5.
traffic on a rainy day, and
So after rainy day, either it's heavy traffic or not heavy traffic. Same over here, right?
right, sir.
We know heavy traffic it's 0.5, right? So it would also be 0.5. The sum of each branch would be 1. See, this would be 1. This would be 1. This would also be 1. Because earlier it's your complete sample space, which is split into two parts, rain and not rainy. Now considering rain as your sample space, it is split into two parts, heavy traffic and not heavy traffic. Okay. And considering your clear day as a new sample space, you are splitting it into two parts, heavy traffic and not heavy traffic. That's why it's will always add up to 1. Okay. One thing to keep in mind. So yeah, not raining and heavy traffic, its probability is given to be okay. And a non-rainy day, heavy traffic, it's 0.25.
So 0.25 and 0.75.
175, right? Okay, next
Next, we have two
branch would be,
situations.
yeah. For each, we have two situations, right? Late,
Not late.
not late. Late, not late. Late, not late. Late and
Not late.
not late, right? And
Sir, here also it's sum will be 1.
Yeah,
Plus
yeah.
not late.
At every branch, the sum should
every
be
branch
1.
would be 1, because what's happening is it is your complete sample space. Okay, you have partitioned your sample space into two parts, rain and not rain. So it's adding up to 1. Now considering this rain as your new sample space, you are splitting it into two parts, only the rain event as your new sample space, so it adds up to 1. Considering non-rainy day as your new sample space, you are splitting it into two parts, so it will also add up to 1. Okay, so now rain, heavy traffic and late, this probability is given to you to be rain, heavy traffic, 0.5, right? This would also be 0.5. And similarly, you can write it down for all the other cases. Okay. If it is clear day and no heavy traffic, clear day and no heavy traffic. So clear day means this part I'm talking about, and no heavy traffic, this part I'm talking about. So it's 0.5 minus 3/8, right? And it would be 1 minus this. So it would come out to be 875. It is 0.125. Right?
Sir, I think it's opposite. It's 0.125 for late, and not late, it's 0.875. I just opened the
Yeah.
question in my rough notebook that I have solved.
So it would be 0.125 over here, 0.875 over here.
Over
And
here,
for all other cases, it's
0.25 and 0.75. Yeah, 0.25 for late
0.25
and 0.75 for not late.
0.75 for not late, right? So we got the all these probabilities. So now probability of being late, this branch you have to track back, right? So it's 0.5 into 0.5 into 1 by 3. Plus second case of being late is you have to track back this branch as well. Right? 1 by 3 into 0.5 into 0.25. Plus again for late, you have to track back this branch. How you are reaching the late part, right? So it's 2 by 3 into 0.25 into 0.25. Similarly, the last branch for late is this. This is what you have to trace back again.
We are just adding up all the possibilities in which a student can be late.
Yeah. So if you
Yeah,
notice,
because it would be or, yeah. So we are writing.
Yeah. If you note, it is the same thing. It is same as rain.
Yeah, sir.
intersection.
It's just a visual representation of mathematical formula, but it
Yeah.
is very simply simple.
And these are the 4 terms we added in the previous, right? So that's how you can approach with the Venn diagram. So it is the being late part. I think second thing is also there. What is the probability it rained that day? Student arrived late, so you have find the probability of arriving late to school. Now you have to find the probability it rained that day. Okay. Probability raining given, right? This is the thing you have to find. So from T diagram, we have computed this thing. Now we have to find out this thing, R intersection L. So for R intersection L, you have to trace back those branches where it is, where you must have R. So R intersection L, let me use different color. So this branch includes R and L, right? And another branch which includes R and L is this one, right? So again, if you notice, it is nothing but R intersection H intersection L, R intersection H complement intersection L, right? So you get R intersection L. So that's how you can approach using the tree diagram.
It's very
There will be no issue now if we visualize all questions with the tree diagram. So like in
Yes, so
stats 2 or something, or we
so
need
far
to.
I haven't faced any issue with the tree diagram. With contingency table, I have faced.
Yeah, contingency table have some
but
issues. That's why
yes,
I have.
yeah, it's not like I
There
am
are
against
some good
contingency
questions
table.
in that book, sir. That Sheldon Ross. I didn't remember the name. I have gone through some questions and the tree diagram there I found, and I found it very useful. But sir, can you explain that question which in which the branches sum is not one? I mean, there is some sort of intersection between them for that cricket and football problem in activity 8.7, I guess.
Yeah,
Or can you do the first problem using
Yeah,
tree diagram to
yeah,
understand
sir.
some other
Yes,
example?
sir. Graded assignment question number 2, sir, that we were discussing earlier.
Yeah, with that also we can grade assignment question number. Okay, this one is clear to everyone before I erase
Yes,
this.
sir. Yes.
Okay, for that, so let's look at that. Where is that cricket football
Yes,
question?
sir. Activity, last question.
Yeah, after that we will go to graded assignment one. This one, right?
Right, sir. 7th one. Yeah.
Suppose
7th.
in IIT Madras, 40% students are girls. Okay. So consider your complete sample space over here, right?
Right, sir.
So girls, another would be boys, right?
Boys. Yeah.
0.40, 0.60, right?
Right, sir.
Next is, it is known that 70% of boys play cricket. Okay, and 60% of girls play cricket, while 40% of boys play football and 50% of girls play football. Okay, so here you will have some double branching, I feel. Double branching, and then the intersection part you will have.
So that double branching is not summing up to 100. That's the contradiction I'm facing.
Double, why would it would, right?
because there is an
70%.
intersection.
70% of boys play cricket.
By double branching, SAR meant, I think SAR means cricket,
Yeah,
football and
cricket and
cricket,
football.
so all those things. That is the double branch SAR meant. It means it did not mean just two branches.
Yeah, here you will have two branches, and they will also have some intersection part between them. Yeah, that will also stuck with tree diagram a bit. It will cause some trouble over here in visualizing. So if you go here by, let's try cricket and not cricket, right?
Right, sir.
And football and not football. Then also you will have some intersection between cricket and football. Some
Exactly.
intersection parts. Yeah, that's where it would stuck. Yeah, tree
But
diagram visualization.
how to approach this question like in the intersection is given? That mathematical approach is the only option.
Yeah, mathematics, because you can't, whenever there are three factors.
But sir, I find
involved,
it I find trouble by visualizing the mathematical interpretation from the sentences given. That's why I have approached this tree method, because it gives clear representation. But I think that's the mathematical interpretation is only the option here.
Yeah, for this,
Can
because
we-
it will go in 3D a bit. Yeah.
Can we use tree diagram if the events are disjoint or separate, independent?
Yeah.
Not disjoint.
Disjoint. It should be disjoint.
It should be disjoint, Shiva,
Like
and all
girls
questions
and boys.
for total probability and the Bayes theorem is the all solvable with this tree method.
Yeah,
It
because
is-
girls
it is-
and boys are disjoint, then cricket and not cricket would also be disjoint, right?
Right, sir.
But if I add double branch, football and not football, it is having something in common, football and cricket.
So it is
That's
not
where-
solvable with tree method, right, sir? That's what I have interpreted so far.
It will have some complex tree diagram involved in. Let's not go into that deep. Yeah, but from simpler one, it won't be visualizable easily.
Okay,
Yeah, from
sir.
simple tree
So then
diagrams.
what
it will be possible.
contingency table is it possible?
Something else? Can you repeat?
Contingency table, is it possible to solve this question?
From contingency table, okay, I think from contingency table,
it would be more complex.
How will we do girl and boy over here? Did anyone try contingency table? Some two guys are mentioning. Have you tried this question using contingency table?
No, sir.
I have tried it, sir, but I just our Venn diagram I that don't remember it, but I tried it by this one.
Okay. Football. Yeah, from Venn diagram, you can visualize it, but it's gonna be a bit complex. If you look at it, suppose this is your Venn diagram, okay? Complete school, all students. First partition would be
Girls and boys.
Girls and boys.
Right. Let's say
And
this
then we
is
have
your
two, yes.
cricket and football.
Yes.
So you will have some intersections, you will have some within all, right? That's the only visualization thing I can think of right now. Because here also you will struggle cricket and then not cricket, and then you will also have football and cricket also have intersection. It also go in some 3D tabular format.
Sir, what if we calculate the intersection part with the formula and then visualize in the tree? Is it possible or not? Like intersection is given.
See, that would involve some higher dimensional tree diagram. From 2D, it would stuck.
Okay, sir.
2D. Yeah, so sometimes you need to be aware of. See, mathematical one is where you can solve each and every question. That's it, right? Okay, yeah. Anything else, anyone?
Yes, sir. Graded assignment question number 2. Through sir tree diagram method.
Graded
So, sir,
assignment.
for this tree diagram, do any book we need to refer, sir, or on this?
You can like online. See, in today's world, everything is available online.
You can search it on YouTube, Bishant. It is available. Like lots of demonstration is there, or you can refer the book which is in portal, Sheldon and Ross.
Okay, okay. I have that book, but I don't know.
But Bishan, do some practice because visualization needs some practice. I have done many mistakes, then I can solve questions with tree method.
Okay, okay, yeah, thanks.
Okay. Who's in this? Yeah. So the question we did by tree diagram, were you able to understand it? But
Yes,
is that
sir.
clear?
Yes, sir. Yes.
Yes, sir.
Okay. Question number 2. Okay. A and B predicting the same score, same round score. Okay, that we can do, but I don't think it would give much.
There is no intersection, sir. It can be solvable.
Yeah, it is. Okay. You have to just think of the branches. They have predicted the same score. Okay. And not same, right? This is my event E, this is my event E complement. And after that, I can make 3 branches. E1, E2, E3. So no correct, 1 correct, right? And both correct. Same 3 branches over here. Okay. It's then you have the probability for all of these, right? For this you have. So what we had to compute is probability of what we had to compute was predicted the same score, find the quality, both are correct. Given E, you need to find E3, right? So it is nothing but E3 intersection E over probability of E. So to compute probability of E, you need to take into consideration all those branches which include E, right? This branch, and this branch, right? So you can visualize it from here, but you still don't know the probability of them predicting the same score, right? You have to do the calculation.
E2 is 0,
part.
right, sir? E2 is 0. E2
Yeah,
is
that
0.
would be 0. That would be 0. But this part, probability of E, you need to compute it. You must do some mathematical thing. But yeah, you can visualize it from the tree diagram. But all are the possible cases you will have it. Okay.
Okay.
Great. So mathematical calculation is the one thing which you will always have to keep in mind whenever you are, whichever method you're using, tree diagram or contingency table. Whenever it fails, you must have a backup of mathematical computation. Yes. Okay. Anyone, anything else? Yeah.
I have a small thing like rule of total probability and Bayes rule. What I have interpreted so far, like for example, if we have 2 bags, sir, and we have 2 colored board, for example, black and white. We have 2 bags and we have 2 colored balls.
Okay.
We just draw out a ball randomly. So if the question asks the probability of white ball or black ball, right?
Yeah.
So we have to use the total probability.
Yeah.
But if question asks like if the ball is drawn is white color, what is the probability that it is drawn from either first bag or second bag? Like probability in between. If we visualize from tree diagram, then we have to use Bayes theorem or Bayes rule.
Yeah, Bayes theorem. Yeah.
I have interpreted is correct, sir.
Yeah, it's correct.
So one more small doubt. I think it must be clear for all of them, but I find it pretty confusing, sir. For example, if we take disjoint events and independent events, I know what disjoint events are and what independent events are by the example which ma'am has provided. But some questions have independent events which are like disjoint and which are not disjoint. Are you getting me? Like it is some sort of intersection in between them. For independent events, sir.
Yeah, for independent, they would have some intersection. Yeah.
how to differentiate between them, like for mathematical approach, some question needs mathematical approach, so there are some sort of formulas which are described for independent events and disjoint events. So how to
Yes.
differentiate between two, so can you explain?
Disjoint events and independent event you are referring.
Yes, sir. Disjoint events, event one is cannot be in event two. The outcome must be different, right? In Venn diagram, the two circles are different. There is no intersection.
Yeah.
That what I have got for in disjoint events, right, sir?
Yeah.
But for independent event, it may or may not be, like it may be some intersection happening there or may not be intersection happening there.
There
Am I
will be
correct?
happening. Intersection will always be happening.
Intersection will always be happening in independent event, right, sir?
Right. Right.
Okay, this is the part I'm not getting. Thank you, sir.
Because whenever we write this, right? If you remember multiplication, okay, you know the continuation probability formula, right?
Right, sir.
A given B.
A given B upon B.
There is some condition in this formula as well. You know about that condition? The condition is probability of B should be greater than 0.
Greater than 0.
Yeah, because it will be not defined if it is not.
No, not it has occurred, right? So if
It has occurred, so it must have been a probability, right, sir?
It must have some non-zero probability, right? So when we write, okay, A intersection B as probability of A given B into probability of B, right?
Right, sir.
And we say that if these two are independent, it is this.
Okay. Right, sir.
Yeah. So for independent event, this term is also assumed to be greater than 0.
Greater than 0. So independent event will always have intersection.
Yeah, always have intersection.
So independent can't be disjoint event. Cannot be.
Yeah, disjoint. If they are disjoint, they can't be independent.
Okay, sir.
Then I think, sir, I have to modify my notes. I have written independent events. It has 3 sections: disjoint, joint, and 3 independent events are happening simultaneously. So you are saying it cannot be disjoint and independent simultaneously.
Yeah, they can't be.
Okay, then for that case, what would be the, sir, E union F? If E and F are 2 events, E union F would be probability of E plus probability of F minus intersection. For independent, sir.
For independent, yeah, you can write it as probability of E.
And intersection part would be just product.
Yeah.
E intersection F would be just product of 2.
Yeah.
For disjoint events, sir, product would be 0, like intersection would be 0, and union it would be the plain sum.
Yeah. Yeah, that's correct. Yeah.
Thank you,
what
sir.
if, sir,
this
one
this
of the
cleared
events-
lot of confusion, sir. Thank you.
So what if one of the events is a null event? Can we say that a null event is disjoint or independent of all the other events?
Null event is dependent of all the events.
Dependent.
Yeah.
Okay. But okay. So probability of null event is 0.
Yeah.
So if you multiply the probability of null event with any other event, you'll get 0.
Yeah.
Okay. So null event is dependent on all the is dependent.
Yeah, dependent on all the events.
Okay. Okay.
Okay. Anything else? Anyone?
But sir, intersection of any event with null event will always be 0, no, sir? So
Yeah, that's why I'm saying should be greater than 0.
Okay. Okay. And can we say null event is disjoint with any other event?
Null event is disjoint. Yeah, disjoint with everyone. Every
So
other.
null event is disjoint with any other event, but it is dependent on any or not
On each of
independent
these.
of, not independent of.
Yeah.
Okay. Okay. Okay.
Okay. Anyone? Anything else? Well, that's it for today. I think we also have tomorrow revision session for week 7, 8 as well, right?
Sir,
Yeah.
no, sir, in my dashboard, sir,
Yeah.
I mean, this statistics marks, sir, assignment 7, assignments week 7, I have submitted, sir, but it is showing
Okay.
zero, sir.
You have to write to support team for that. Only they can do this backend problems.
Okay, sir. One more thing, sir. I mean, marks has been calculated like for I mean best 5 out of 8, right?
Best 5. Yeah, it's mentioned in the grading document, right?
Yeah, but they have counted. They have taken average of, sir, all the assignments, sir. In my case.
It is, see, I think the average score is calculated for all the assignments, but to calculate if you are eligible to write the final exam or not, they take the best 5 assignments from the 9 and then calculate the average score.
That's best 5 out of 9 weekly assignments. Score your average should be greater than equal to 40 for eligibility to write final exam.
Yes, sir.
But the average score they are showing, which I'm sorry to interrupt, the average score they are showing here, it is for all the 8 weeks.
Yes,
Yeah,
sir.
so it's 8 week. Okay. See, so it's showing for 8 week, but as soon as you submit your 9th week assignment, it will show you for all the 9 weeks as well as the best 5 of the 9 weeks. So you will get whether you are eligible to write the final exam or not. And attendance is one of the 2 quizzes also mandatory. Okay, so you can calculate yourself also what's your best 5 average coming out to be 8 and check out the score requirement in week 9.
Yes, sir. It's got it, sir. And best 7 out of 12.
All 12, yeah. Yeah, it would be considered in your final score.
Because actually, sir, I mean, for sitting in an exam, it is showing 9. I mean, 5 out of 9 week assignment, right? But it is showing average, so that's why I'm just saying.
Yeah, average. Yeah, for that it would be only that considered. So it is just showing your average score till now. It's nothing to worry about.
Okay, sir. Thank you.
Sorry to interrupt, sir.
Yeah. Okay, anything else? Anyone?
That'll be all, sir. I think from my side.
Okay.
So there'll be 2 mocks or just 1 mock?
1 mock this time.
On Wednesday.
Wednesday
okay.
morning it will open and it will be available till Thursday 5 p.m.
Okay.
And sir, how many revision sessions will happen?
For week 5, 6, it is already conducted, right? For week 7, 8, you will have tomorrow. And then after mock, you will have 1 mock revision session. And we will be having some on-demand session next week. A lot of on-demand sessions we will be having.
Okay.
Okay. By the way, what timing is convenient to those who present for on-demand session to all of you?
8 to 10.
Okay, so now, if I remember, we have conducted some sessions around 4:30 and some from 8 to 10. So, do you guys need any other time slots except this, or is this fine?
Sir, any session which does not overlap with any other session it would be
Yeah, it
fine.
won't overlap with any other.
Yeah, it would.
And
We are fine,
and
sir.
it should also not be between say 10 to 6, sir.
Not between 10 to 6. Okay, it
Yes,
means
sir,
8 to 10 is the good time you are think, right? Okay, what about if we do 10 to 12? Will it be too late for you guys? Or-
No, sir. No, sir. Late night we are comfortable.
Yes, sir, we are comfortable.
Okay, we will look into it. Okay, guys, thank you everyone. Good night. Yeah.
Thank you, sir. Thanks a lot.
Good night, sir.